Are you tired of overcharging your laptop and overheating issues? Imagine having a smart system that automatically stops charging at 100%. Welcome to the part 1 of this exciting series where we'll dive into creating a Python script to monitor your laptop's battery percentage and send this data to Firebase for wireless automation. Isn't it exciting? Let's get started. First, we import the required libraries. psutil is a Python library that provides detailed system and hardware statistics, including battery percentage information. The Firebase admin library is the official Firebase SDK for Python, which we use to authenticate and push data to real-time database. Next, we need to initialize Firebase. To connect securely, we use a service account JSON file that you download from your Firebase project settings. This file contains credentials that authenticate our script with Firebase. The Firebase admin.initialize app function sets up the connection between our script and Firebase. We pass it the credentials and the database URL, which you can find in the Firebase real-time database settings. Defining the getBatteryStatus function, this function retrieves the battery percentage whether the laptop is plugged into power. We use the psutil.sensor_battery function, which returns an object containing battery status. From this object, we extract the percent and power plug attributes. The function returns two values, the battery percentage as an integer and the charging status as a boolean, defining the send to Firebase function. In this function, we package the battery information into a dictionary, the key, battery levels, and is plugged corresponding to the value we retrieved earlier. We use the db reference method to point to the laptop battery node in Firebase. Here we'll store this data. Finally, the ref.setData method updates Firebase with the new data in real time. In the main part of the script, we repeatedly check the battery status and update Firebase every 30 seconds. The loop starts by calling getBatteryStatus to retrieve the battery percentage and plugged-in status. Next, we pass this data to the send to Firebase function to send it to the Firebase real-time database. The time.sleep statement ensures the loop runs every 30 seconds, avoiding excessive network usage. Now let's quickly set up the Firebase real-time database for this project. If you don't know how to do this, please refer the video in the description box or simply click the I button. We'll now integrate the Firebase admin SDK with our Python script by providing the path to the service account JSON file and the Firebase real-time database URL. Now that we have initialized the Firebase admin SDK in our script, let me guide you through downloading the JSON file and obtaining the real-time database URL. In the left-hand menu, click on Settings and then select Project Settings. Under the Service Account tab, find the section labeled Firebase Admin SDK and click on the Generate New Private Key button. A JSON file will be downloaded to your system. This file contains credentials required for our script to authenticate and interact with Firebase. Once you have the JSON file, place it in the same folder as your Python script. This ensures our script can easily access it without needing additional path configuration. At the top of the database screen, you'll see the URL for your real-time database. It typically looks something like https:// and so on. Copy this URL and paste it in the database URL field in our script. Update the file path to match the JSON file name as I have shown. The JSON file serves as the private key to securely authenticate our script with Firebase. The real-time database tells Firebase which database to connect to, enabling our script to send and fetch data. With the JSON file in place and the URL added, we are ready to test the script. Run the Python script in your terminal. As it executes, the data should be sent to Firebase and you will see updates in real-time database. This setup ensures that our Python script can seamlessly interact with Firebase, enabling real-time updates of our battery percentage and charging status. In part 2, we'll take this further by connecting the ESP8266 to Firebase and using it to control a relay module for the smart switch.